So I welcome all the participants to this online faculty development program on cloud and fog computing platform for IoT application. So today we have in the second week, day 6. We are in day 6. So today we have Professor Debashis there with us. Sir will discuss about Internet of drone things. So before Sir will start the session, I'll introduce Sir to this to the participants. Professor Debashis Dey is a professor in the Department of Computer Science Engineering at Maulana Abdul Kalam Azad University of Technology, West Bengal, India. He received M.Tech degree from University of Kolkata in the year of 2002 and a PhD from Jadavpur University in 2005. He is a senior member of IEEE, fellow of IETE, and life member of CSI. He was awarded the prestigious Boys Cast Fellowship by Department of Science and Technology, Government of India, to work at Heriot-Watt University, Scotland, UK. He received the Endeavour Fellowship Award from 2008 to 2009 by DEST Australia to work at the University of Western Australia. He received the Young Scientist Award in the year of 2005 at New Delhi and in 2011 in Istanbul, Turkey, from the International Union of Radio Science, Belgium. In 2016, he received the J.C. Bose Research Award from IETE, New Delhi. In 2019, he received the Shiksha Ratna Award from the Government of West Bengal. He established the Center of Mobile Cloud Computing for IoT application. He published more than 400 journals and 200 conference papers, 15 books, and filed 10 patents and 4 granted patents. He has executed several projects sponsored by AICT, UGC, WBDST, DST, World Bank, AWS, and MIT. His H index is 43, and his citation as per the Google Scholar is more than 8,700. He supervised more than 20 PhD students. His research interests include mobile cloud computing, artificial intelligence, machine learning, IoT, and quantum computing. So, with this introduction, I request Professor Debashis there to start the session. Sir, please.
Thank you very much. Thank you for calling me for this event. And I must thank to the organizers for this, especially Sanjay Kumar Panda, for organizing this beautiful event on edge computing. And today I'll just highlight some of the topics related to edge, and where I'll be discussing on how this IoT works along with edge. And the topic of today's lecture is Internet of Drone Things for Sustainable Smart Cities and Society. And as you know, the IoT is capturing the whole world, and all the things happening in the world is through IoT only. Can you see this slide?
Yes, sir.
Okay. So you can see that IoT, as you say, that Internet of Things, right? What is Internet of Things? Anyone can say what is IoT? Feel free to participate. We'll have an interactive session for next 1.5 hours. So feel free to participate in the discussion. If you want, you can write in the chat box also, or you can unmute and speak, or whatever. What is Internet of Things? We all know IoT, but how it works? How this IoT works?
Sir, it's a network of physical objects,
Okay, correct.
and it's a network of interconnection of heterogeneous objects.
So
Or
suppose you connect one laptop, one mobile, and one, say, tablet. So
yeah,
they're all heterogeneous connectivities, right?
yeah. For example, devices, vehicles, buildings. So that's
Yes.
heterogeneous, different
Fine.
configuration of
But
each.
is it IoT?
It's a broader term, that a broader definition that I have said. It would be consisting of networks also. It would be consisting of sensor also. It would be a communication between a machine to machine. So it's a broader thing, like not exactly
Yeah,
outline.
yeah, I understood. We are talking about the connectivities.
Yeah,
But my question is that is this connectivities means IoT? What is actually IoT? It's actually connecting the network means connected networks, internet, LAN, MAN, WAN, you can say. But actually, how IoT works? Anyone, any other person can try?
The things among them communicating without human intervention.
Yeah, if you connect to 4 5 laptops, if you make autonomous system without human intervention, is it IoT? No, this is not
No, sir.
IoT. I'm just asking you for some keywords. Anyone, any more definition or any more thoughts? You're close, but not exactly, But anyone, any more definition of IoT? You have to understand IoT first, then we will go for IoDT, Internet of Drones. So today we are here for we will do a informal discussion also. Uh, Otherwise,
it
it will be difficult.
it can be connection within like embedded with the electronic software or sensor, and these object that enables these object to collect and exchange the data in IoT.
Yeah, but collection, exchange, this is all basically networking. But I'm talking about something different. How IoT works? What is the meaning of IoT? Internet of Things. What is the purpose of IoT? If you talked about network exchange, information, communication, heterogeneity, mobility, everything is fine. But is it IoT? Answer is no. This is not IoT. IoT is something different. Just try. Everyone know in this platform. Those who are present, everyone knows. Maybe you cannot express, but you know it. Yes,
Devices as well as communication between cloud.
devices as well as
Communication between cloud and device.
cloud and device. Fine, but is it IoT? If you connect a device with the cloud, is it IoT? This is a cloud connectivity. It provides services, right? But what is actually IoT means? My question is, what is Internet of Things, right? We all know that for last 10, 15 years, IoT is a big buzzword, right? You have Alexa in your home? Can I give the answer, or anyone more will try? Anyone more in this room?
Like according to previous lectures and previous knowledge, it's consist of mainly three things. That is, first I've said that network of devices, second is data, and third is devices. So network, like this whole three, like if we make the Venn diagram of all the three things, that
Mhm.
would combine to the definition or the meaning of IoT.
But okay, let me explain now. Is it okay? Let me explain. Madam, do you use this Alexa or Google Siri? Anyone? Right? Do you use Alexa? Any one of this participant who use Alexa or Google Assistant? Anyone? Anything? Yes. Hello. Anyone, please? No one. Okay. So if you have Alexa, you know that if you give a voice, Alexa, what is the temperature outside? Alexa, play a song for this beautiful sunny day, right? Alexa will play the song. So actually, using this voice, we are controlling the Alexa. Alexa is the IoT device, right? Control is the most important term for IoT. Using this IoT through the internet, first step one is you have to connect all the devices through internet. Second step is you have to control the device, right? You have to control the device through this network connection. That is called IoT. Control. Is it clear? The control? Madam, is it clear?
Yes, sir.
So, we can, I am now at, say, a place called Kolkata. My house is at Calcutta, which is around 50 kilometers away from this place, right? Now, I can switch off my light in my house or switch on my light from my mobile phone here. From this mobile phone, using a voice control, Alexa, switch on my light at home. It can do it. Or you can have a remote control systems through which you can control my lighting system or any kinds of devices, right? So controlling, either it is in front of you or by remote control, means long distance. So actually that is called IoT or Internet of Things. That means we can have the control, that we switch on and off, switch off, or give some operation. That is called IoT, right? This is called Internet of Things or IoT. Clear? Now, by this process, actually, Internet of Things, actually, we control the whole system for the cities. The cities and society, we are all connected. We are connected to Internet. Everyone is connected through Internet, and as a result, we are also called social IoT. If the drones are connected, you can see multiple drones are there in this picture. These drones are connected to each other through the Internet. This is called Internet of Drones, right? One drone can control the operation of other drone. That is the beauty of Internet of Drones, right? And these drones work together, just like a flock of birds. They're working together. They can fly on the sky. They can perform the operation. They can do certain jobs. And by this process, actually, these multiple drones are flying on the sky. They are performing the jobs together. For what? For cities and society, right? So this is the operation. Actually, we'll discuss next 1.5 hours. We'll be discussing how this Internet of Drones works and how this operation is possible. So first part is how it is IoT works, Internet of Drones. So before I start, we have a center of mobile cloud computing. Center of mobile cloud computing, where we deal with the data from the mobile phone itself, which is combined, connected to the cloud. Actually, everyone know nowadays that we are using apps, right? Mobile apps. And using the app, we can control anything. We can call a Ola, Uber, or if you are hungry, you can give an order in Zomato, right? We can do anything in the apps. Nowadays, apps are so powerful. And apps has a magic of connecting the world to the cloud, right? And actually, the apps are actually controlling the IoT operations, whole IoT operations in the system. So I have written this book in 2015. Starting from 2010 to 15, I have completed this book, 2015, okay? Where actually, the apps are actually connecting to the whole cloud operation and by this process. So this book is all mobile cloud computing. Mobile to cloud. Actually, if you use a smartphone, see, all our data is in maybe Google Drive, all my pictures in some other websites. So we are all capturing the data and putting somewhere, right? So this huge data, thousands of images, we are putting in the cloud. So mobile cloud is the most important platform nowadays. Okay. And we do the research with mobility, vehicular data mobility, drone data mobility, all this smart city operations. Okay. Now there's drones. Actually, you know that drones has 4 wings. Everyone know that it has BLDC motors, and these BLDC motors are available in our fans, low cost. That low power fans, they use BLDC motors. And when these wings moves, and it is 4 wings, it gives the upper thrust. Then if it is the up thrust is greater than the weight, then it is called takeoff. That means when the lift is greater than the weight, this drone will move on the sky. And after getting on the sky, it releases the pressure, means 4 wings. When lift equals to weight, then it will hover on the sky. Hover means it will fly, but it will stop in certain direction. certain position. But when its lift is greater than weight, from the land it will go on the sky. So this is the way the drone works, right? You know that
Sir,
yes, yes.
sir, we are unable to see the slides are not changing from our
Is
side.
it? But it's changing from my side. I think I have to switch off my. Okay, I'm initiating it. Just a minute. Is it visible now?
Yes, sir.
Please tell me any problem. Please tell me. So these are the wings. You know that drones actually 4 wings. Can you see these 4 wings and weight? Weight is giving weight on the land. This weight of the drone, and these 4 wings are helping to take off. And 4 wings are moving clockwise. 2 wings are in clockwise. Other 2 wings in the anti-clockwise. This is the most important. 2 in clockwise and other 2 in anti-clockwise. By that process, actually, drone will move on the sky, right? So if these 4 wings move in same direction, it will just circularly rotate. So these are the various rotational movements. Even nowadays, drones can carry the human being. Can you see this picture? The person on the this is the person on the drone. It can carry 130 kg weight, and it has around 8 wings. Maybe in future, all of us will be traveling to our destination using the drones, right? Nearby destinations, without using the bicycle. Maybe we'll be using the drones to move to certain place. With less condition, we can go to one place to other place, right? The drone-based driving systems are now becoming so popular in many countries, every country. Yeah.
Sir, is it possible to have a three-wing drone?
3 wing.
Yeah.
Actually, to balance it, 4 wings are better. 3 wings difficult to balance. Balance is important.
Okay.
But if every wings is giving the thrust. You can see the thrust on the land. By that way, actually, drone moves on the sky, right? But if you see this human being, it has 8 wings. Why 8 wings? Because it has 8 fans, means 8 rotation, and it gives more thrust on the ground, on the wind, and it can carry the human being 130 kg. So if you want to increase more weight, 500 kg weight, you may have to give 16 wings. Okay, more weight, more wings. Clear? But in terms of 2 to the power n, 2n means 2n structure. 3 is not possible, but 4 is possible, 8 is possible, right? 12, 16 is possible. By that way, it increases, multiplies. Okay. Is it clear? Now, see, when we are talking about the drones, but I've discussed what? Drones are working in the cloud, right? So drones are also edge device. There's a device which works. But in certain operation, nowadays we are using the cloud, right? Where is the Amazon cloud? Amazon is so popular cloud. Where is the position of the Amazon cloud? Can anyone say? If you are using Amazon AWS, what is the location of the cloud? Can anyone tell me? It is in Mumbai. So if you want to perform any operation from Calcutta or Delhi, data have to travel from Calcutta to Delhi. So huge cost is involved and huge delay is involved, right? So to solve that, we are using what? We are using edge devices, edge computing, because our mobile phones are also very popular. Means that it becomes, I think, memory is very high nowadays, right? Nowadays, mobile phone has 8 GB RAM. It can also compute. A single mobile phone can handle 1,000 drones, 100 to 1,000 drones. If it can handle the drones operations by itself in the using a single mobile or a laptop, then we must not go to the cloud. We'll perform all the operations in the edge itself. Agreed? Agree or disagree? If your mobile phone can handle 100 to 1,000 drones operations, means you can operate, you can control 100 drones using a mobile phone, we will not go to the cloud. We'll do it from the edge device. And that is the control or the power of the edge network, right? What is the advantage? We have billions of edge devices, but only few thousands of cloud. So when we will be using the edge devices, we can perform the operations in a very faster fashion. What is the advantage? What will be the advantage of edge over cloud? There are two major advantage. There are two major advantage of edge devices over cloud. Can anyone tell?
Sir, latency and power.
Latency and
So power and cost.
power. Yes, latency means delay, right? We can reduce the delay. We can perform it more reliably in the edge level. So delay will be less. So drones will be operated in a real-time fashion, right? If there is any delay, then a lot of accident may happen, right? So these are the advantages of using these, edge devices, drone devices, right? So these are the very important applications of edge. So mostly we are now interested in edge. That's why if you see that 30 years before, everyone is talking about cloud. If you see the research papers, everything is on cloud. Still we are using cloud. We are using Gmail in cloud. We are using Google Drive, OneDrive. Everything is on the cloud. But we are mostly relying on the edge devices, edge operations, right? Yeah. But in between, we need some operations in the, say, suppose in your college, suppose in NIT, we have some server, we call it fog devices. So, but mostly we'll be relying on the edge networks. So if you see the smart city, the drones can have, that connected to the sensors, the traffic signal it can control. Suppose the car is running fast, not obeying any signal, this drone will go capture the image of the person who is driving the car and what is the car number. Within a fraction of a second, it will send an SMS. Okay, you have to pay, say, 1,000 rupees fine. So drones are actually managing the cities. Smart city operation, these drones are playing a major role. When the light will be green or yellow or blue, everything will be controlled, right? Also for the smart home, drones are doing the delivery of product delivery. You know that drones are now very famous for it, very popular for it. In hilly areas, especially, drones deliver the medicine, the products. Even the Flipkart, Amazon is thinking delivery through these drones, right? Clear? Now, also, if you can see, these drones are also using for smart grid applications. So there are various applications from traffic signal control to delivery to home health care to power grid. All the drones are connected to each other and they're performing their jobs. And listen, they're all doing edge level operations, because every drone has their own computing capability. And these drones are mostly autonomous in nature. They can do the operations by themselves. That's why we call it autonomous drones. I think some of the participants have mentioned that it can do the operations autonomously. Yes, correct. One drone can send the data to other drone autonomously, right? If anything help support required, they can talk to each other. One drone can talk to other drone from this system. So by this way, this drone can connecting to each other and performing their jobs. And they're all connected drones. That's why we call it Internet of Drones or Internet of Drone things, right?
Sir,
Yes.
sir, to control these like drones or these smart devices from the edge devices, so there would be a storage would be needed to control this or to like control the drones from our edge devices.
Yeah, actually, if you see our laptops, we have SSD drives, right, madam?
Yeah, so yeah,
Your 512 SSD drive is capable enough to handle 1,000 drones. We checked it.
no, from like we were talking about mobile and all that. So that's what my question was like the cloud solves the problem of storage
Yeah.
mostly. So how the problem of storage in case of these edge devices is solved
Okay,
if we
fine.
are not using cloud?
Yes, yes, I'm telling you. This drones, suppose this 3 drone is connected to your mobile phone. It will take 1 GB of your system, of your mobile phone. That's it. If it is maybe 100 drones in your mobile phone, it will take maybe 2-3 GB, right? So your 2-3 GB is sufficient enough to handle this operation. And moreover, this drone itself has SSD drives, solid state drives, right? It can store their local data, localized data. Whenever required, we can call the data from the drone to your mobile phone, right? That is also possible. So locally it can store the data. Sometimes in your mobile phone it can store it. So local operations can be handled by these drones. So
And sir, that local data which is handled by the individual drone, so how the security of that data is considered like
yeah, it is more secure. If you want to go send the data to the cloud, compared to that, it is more secure. In my slides, we have on security also more private. Privacy is also preserved. I'll explain it. I'll
So,
explain the two operations of security and privacy today. Okay.
so what about the machine learning model if you are involving? Then how it will like if these devices are resource concerns, so how they will predict some like object detection or anything like that?
Yeah, you know that we have to use lightweight machine learning techniques like YOLO. You know, YOLO is very common and popular. This is lightweight. We do not need any very high-end RAMs and memories, right? So for the drone computing or drone, what you can say that machine learning techniques requires lightweight programming techniques that does not require heavy complexity or heavyweight architectures, right? So lightweight encryption or lightweight machine learning is used for this drones. Okay, so I'll explain it. I'll go to the machine learning part later on. But this drones are actually very efficient. You know, it can capture the images and perform these operations very efficiently. If the data size is huge, then only will go to the cloud. Otherwise, most of the operations are performed locally. Suppose this drone can handle say 1,000 cars, that will handle it simply. It will not go always to the cloud. Maybe in a end of the day, maybe end of the week, it can send some reports. That's it. But locally, the daily operations, real-time operations, it can help.
So basically, we can say that the applications is most important of where we are using.
Yes, yes, and it is distributed nature.
Okay,
Nature
thanks.
is distributed.
Yes.
And another thing, you know, if one drone data size is very huge, suppose this drone is idle, it will send the data to the nearby drones to handle the operation, right? Or it will call this drone, please help. This drone will come and help this operation. In this picture, I have shown only 3 drones, but it can be 100, it can be thousands, right? And most of them are autonomous in nature. Autonomous means no external operation is required. Generally, it can fly by themselves, right? Because they're intelligent enough to understand the situation, and they are intelligent enough to handle the situation, the operations, like a robot actually, like a humanized robot. These drones can operate. Autonomous drones are a little bit costly compared to the normal drones because lots of softwares and hardwares involved. Lightweight, all lightweight, mind it. So drones are landing in the air, right? What they are learning? They are learning how to communicate with each other in the air. They are learning how not to collide to each other. If someone is collide to other, it will cause an accident, right? You'll keep a minimum distance from one drone to other drones. So they are learning all the operations, how to collect, how to handle the large data in a distributed fashion. Distributed means distributing the data among the drones, among the cluster of drones. So we call it learning in the air. Drones are learning in the air. So we have to give the intelligence. We call it mobile edge intelligence. We have to give the intelligence to the drones, right? So we have written 2 books. One is called Mobile Edge Computing. Now we can explain. These books are available freely online in Springer. Those who are interested, you can study these books. Where my co-author is also Annisha Rajkumar Bhuya, Shomakanti Ghosh. I think you may know Shomakanti Ghosh. He is a NPTEL lecturer on cloud computing. He is the author of NPTEL India Government MOOCs program, right? SK Ghosh from IIT Kharagpur. And Rajkumar Bhuya is from University of Melbourne. We have written this book only for edge computing and mobile in nature, means mobility. So we call it mobile edge computing, right? Your drones are also one kind of mobile edge devices where we are performing these operations in the computing. So this book has 22 chapters. Also, there is another book we have written called Artificial Intelligence in IoT. How AI is coming to this IoT environment. That is also explained in this book. Okay. What kind of machine learning techniques? I think you have asked the question that what are the intelligence and how to program. This is given in this book, right? How to give the intelligence to the drones, especially IoT devices. So that is the reason of the book is AI for IoT, artificial intelligence based Internet of Things. Okay. So these 2 books are available in Springer link. Now we have, as you have discussed, that we have 3 levels of intelligence. Centralized intelligence in the cloud level. We can use heavy algorithm, means large language models or deep neural networks and all high-end algorithms in the centralized servers in the cloud. In the mobile towers, we are using this mobile edge computing in the local intelligence. And in terminal, we are using terminal intelligence, or these are the intelligence, right? This is very lightweight. And especially, as you have asked, the drone intelligence is known as terminal intelligence, which is lightweight and very efficient. Lightweight is very important. Complexity should be less. So you can see this drones must fly by themselves, and suppose a drone can see certain people are lying on the ground, they'll do some edge computing in the local server and perform this. They give the signal to the control room. The control room will send the ambulance to recover these 2 people. So this is the purpose of autonomous drones. But at the same time, 2 person is lying on the ground of a road and some fire is happening, then they will send ambulance for the fire, ambulance for the people, and ambulance this fire brigade to stop the fire. So drone is giving intelligence, so no one have to call physically, okay, send the ambulance or like this. Drone will do all the operations autonomously. So that kind of intelligence is given in the local level, terminal level. So this is the terminal intelligence. This is the intelligence, terminal intelligence. Now, see, these are the various applications of drones. Infrastructure, agriculture, transport. Agriculture is huge market, especially country like India. We are all working on mostly on agricultural drones. Many companies are working on these agricultural robotics or agricultural drone operations, right? So a lot of people are working in this domain of agriculture. Also for border security, these drones are, India has a lot of border, right? In the north, in the south, in the, they have a lot of borders, and especially in the freezing temperature, the drones are operating in the low temperature zone also. Also for telecommunication, mining industry, underground mine operations, drones are very useful, especially in agri drones. I told you that we don't have to give the pesticides in full ground, only to the affected area. These drones will go, they are connected to each other, they are performing these operations, and actually they are spraying it on the ground in the affected zones. That is called agri drone, right? By this way, actually, we are actually performing these operations in the ground level. And as you see, these drones can, like a bird, it is flying along with the birds. This is a comic picture. It can carry volume, velocity, and variety. These are the three V's of big data: volume, velocity, and variety. These are the three V's which can handle. So it can handle huge amount of data, right? So can you say that when IoT is combined with the drones, it's like an elephant is flying. Elephant means huge, right? It can carry huge amount of data, say full 7 days data of a certain zone, or say traffic data, or agricultural data, or forest fire data, or any kind of data it can handle, right? So drones are very powerful, like a elephant, means huge, powerful in the sense huge. So we can also, that we can say drones are like a Superman, which can handle huge operations, right? It's very useful and very powerful. Drones are nowadays so powerful in two ways, because it is performing the edge computing, which reduces the latency and delay. It can perform in real-time fashion. Number two, drones can connect with other drones, so they are so powerful nowadays, right? It can do any kinds of operations in the smart city applications. So it is like a Superman or Mandrake, right? Now we have discussed about the drones for sky, or UAV. Also we have AUV. AUV means acoustic underwater vehicles. Means we want to connect the drones on the land, also under the water. We call it underwater drones. So actually our target is to connect the three layers: Shargo, Morto, and Patal. Three layers, right? We have to connect the networks or the devices on the sky using the flying drones, on the land by grounded drones, also aquatic, underwater. Under the waters, drones can also perform the operations. So these are the three layers of the drones which can connect to each other. Okay. So these are the operations of the drones. That multiple drones, you can see multiple drones are connected to each other. And this PwC, price water, PwC, anyone? This is the company which goes for market forecasting.
Price Water Coopers.
Yes. It's one of the top company for tech forecast. 2016 they said like this. These are the 7 essential qualities of a connected drones. See, and this is the coming truth in 2024. Drones are now autonomous. See, there is written they can fly by themselves. No one need to operate. There is no operator. They are intelligent enough to fly. So they can crawl also, like a baby. They can talk to each other, like a IoT. IoT device means it can control. Talk means control. In the morning I've discussed, first beginning we have discussed that one drone can control the other drones like this. They can talk to each other. They can communicate to each other, right? So this is the power of IoT. They can talk. Means multiple drones are working together, right? They can recognize the face of the object. As I said, if there is any drones there, they can take the image using this YOLO or some other face recognition algorithm. They can recognize a face, right? They can climb on the trees or they can grab the object. Grab means delivery. Flipkart, Amazon delivery. Just wait. Flipkart, Amazon is going to deliver the products within India. Already they have started in various countries using QR codes based. Means you have to give a QR code of your house. The drone will deliver the product at your home. Even if you are not at home, it will deliver the product at your maybe the rooftop of your house or somewhere. They deliver the package, right? They can deliver the essential materials like medicine, emergency medicines. Suppose your parents are not well, you have to give the medicine immediately. You can ask the drone to deliver the medicine. Your medicine shop will deliver the medicine within a few short time to your home. Means real time. This is one of the very interesting operations of edge computing where these drones will operate. The last one is very important. They can give each other space. Means very important. They should not collide. They give each other space. They will fly, but they will never collide. So these are the 7 very important tech forecasts. 2016 they have mentioned. Still it is true, right? These are the some of the drones in our lab. See, you can see some of you have asked how many copters. Can you see how many wings it has? 1, 2, 3, 4, 5, 6. So it is carrying huge. It is an agricultural drone in our lab. So it can carry huge amount of materials. It has 6 wings. Can you see this? 6 wings. We have GPS, flight controller, brushless motors, battery, and RFID. Lot of electronics is involved in here. So these are the actually various challenges of drones: routing challenge, mobility challenge. But most important is the privacy and security. This is the most important part: privacy and security. So today I'll discuss on privacy and security part of it, right? This is one of the work we have published on drones, especially for IoT operations. The topic is edge for QS, quality of service aware MQTT. MQTT means message queuing telemetric transport protocol. Message queuing telemetric transport protocol is one of the very common protocol for IoT, right? Everyone uses MQTT. We are using this QS, quality of service aware MQTT, for mobile edge computing for opportunistic Internet of Drones operations. We have given the name is called edge drone, where actually we provide various types of services to the drones, right? Service providing. So service means here 3 types of service: QS0, QS1, QS2, using this MQTT protocol. What is that? QS0 is a basic service. Like basic service means if you go to any hotel, how many types of rooms are there? Any hotel you go, types of rooms, anyone can say? Based on the quality, please anyone try. I think everyone visit hotel. You visit any place, tourist place.
Five star.
5-star, 2-star. But if you go to hotel room, any hotel, we have a standard room, right? Standard, deluxe, super deluxe, right? Or suite rooms. Based on the price you pay, you have to, your quality will be increased, right? Super deluxe, deluxe, and standard room. Standard means QS0, deluxe means QS1, QS2 means high quality. So if you see, this drones works in the PubSub model, publisher subscriber model. One drone is a publisher drone, other drone is subscriber drone. If you see the connections, only 2 connections, and these are 3 connections. This is the connection of one drone to other drones using a broker called MQTT broker. Broker is the person who can connect one drone to other drones, right? Means one drone can communicate to other drone using this broker. Generally, you go to any place, you want to purchase a house, you have to go to the broker. What is the broker you says that, okay, I have this much budget and I want a 2 BHK or 3 BHK room for my family, right? So this broker will select which subscriber you will go get. Now they connects the publisher to subscriber, right? Agreed? That is the purpose of broker. Similarly, this is called inquisitive broker. This is called pub sub model. Pub means publisher, sub means subscriber. Publisher is one drone, subscriber is another drone. Through this MQTT QS0, their connection is like this. If you go to for QS1, you can see more connections, more lines are there. Means more reliability will be there, right? To publisher to subscriber. Again, it is also MQTT broker. This another broker, you can see multiple connections here. You know, it indicates much more better quality. You can have gizzard in your room. You can have, that, what is that? Even your room has refrigerator, all the facilities. Means multiple facilities. Reliability will be high. Means reliability of what? Reliability of connection. One drone connection to other drone connection will be high, very high. But cost is high because it is giving more better services. So cost will be high. So we have 3 services: QS0, QS1, QS2. So this is the basic service. This is the advanced service. This is a very advanced service, but the cost will be higher. Now, what is publisher? Publisher is one of the drone. Subscriber is a multiple drones. Here in this case, now we are on the Google Meet, right? And hello, we are in the Google Meet, right? Who is the publisher now? Hello, who is the publisher now? Publisher, I am the publisher because I am not talking. Whatever, I am sharing the slide. And how many participants here in this room?
38.
Huh?
38, sir.
38. So there 38 is a subscriber. 1, 2, 3, 4, 5 up to n is 38, right? So you 38 is the subscriber. In between we have a broker. Broker means who controls everything. Who made the Zoom link or Google Meet link. He's the broker. Here you can see your NIT Warangal Professor Sanjay Kumar Panda sir. He is actually arranging the event, right? He communicated with me and he is arranging the session. Means to the publisher to subscriber. So he or the team, his team is the broker, right? What they are doing? They are arranging the publisher, they are arranging the subscriber, and arranging the whole successful communication, right? Is it clear? This Google Meet is the way to connect, right? I'm connecting you using this Google Meet only, right? So this is called brokering. And one publisher have multiple kind of, subscriber. It can be 38. Present case it is 38. It can be 100. It can be 1,000 also based on the link size, based on the data capability, based on the bandwidth, based on the network capabilities. It can increase or decrease, right? So by this way, actually one drone can communicate to multiple drones. One publisher to multiple subscriber. Clear? Now I am going to other direction for underwater drones. I took this picture from Amazon, where you can see this is available in India at 70,000, 3,000 rupees. What is this? Is the underwater drone. This IP65 cable, this is there. So when there is any water, also electronics will not be affected. It has been cased like this. Casing is done like this. So you can see there's 2 lights, 2 searchlights are there. This drone is connected to the cables to the operator. I have this drone in my laboratory. We perform this operation in the river Ganga to find out the fishes and the various objects under the water, right? And it is fun. At the same time, we can enjoy the underwater things. We can explore. We can do a lot of image processing techniques, so for blurring image to normal image. So a lot of research areas involved in underwater drones. This is a new area, especially for when you're having multiple underwater drones, how they can communicate to each other, how they collect the data and come up and send the data to you, right? So this is a very interesting area of research on using these underwater drones. Okay, here this is the camera. Middle one is the camera, and two sides are actually searchlights. Okay, and these are the fins and wings, and there's a cable is not shown in this picture. I have a video also. Maybe sometimes I'll share it to the group. And this cable is connected to the land, or you can do it in wireless also. Wireless version is also available, but this one is not wireless. Wireless version is more costly. Okay, this is the wired version, right? So this underwater drones can be used in mining industry, underwater mines. We have won some projects on underwater mining project. We use these drones for that purpose, right? So using this, simple tablet or telephone, we can connect to the drones on the sky, also under the water. So by this way, we can connect the whole world. So we published one work 3 years before, 21, how to model the software-defined underwater things, Internet of Underwater Things, using called IOUT, using the edge drone operations. Right. So those who are interested, they can see this. Now, drones, that unfortunately drones are used for various operations. So this is the anti-drones. Many countries, even unfortunately the wars is also based on the drone. So this person is using anti-drone. They're using anti-communication. So they find out what is the frequency drone is operating. They actually stop the operations of the drone. Especially in the nuclear power area or in the border zones, we are using these anti-drones. Military uses this anti-drone operations to stop the enemy drone to bombard in your area, right? Also, we use something called drone chain. That means the blockchain. I think everyone know that blockchain works in the hash function, right? One block want to connect to other block using the hash. So drone chain is another operation. So if the hash of one drone 1 to drone 2, the hash value matches, then only the data will be connected. Otherwise not. We call it drone chain. That is the basic operation of blockchain. If the hash does not match, that indicates there is maybe the enemy drone will not allow them to come to the network. So drone chain is one of the very important and secure way to make your network secure. So in this book, we have written this book in 22, how this blockchain can be used for IoT applications, Internet of Things applications. Okay. And how to make the system. All the drones will be connected as a blockchain chain. Each and every drone is acting as a block of the chain, right? So by this way, we can connect the whole drone operations using these hash functions. Now, another very important thing is called glowworm. Glowworm means, you call it glowworm. Have you seen the glowworms in the hilly areas? They are in thousand. They stay in the thousand in the caves, but they can fly, but they never collide. Called swarming of glowworm. We are using the same swarming for drones to operate. What happens is this glowworm, they do not collide. They do not collide to each other. So we are using this same working principle of these drones to our swarm optimization when multiple drones are flying on the sky. So how the drones, actually these drones will follow the same swarming principle. So we are using the same mathematical models or algorithm to our edge drones so that the drones will never collide to each other. So based on this working principle, Ali Khan has developed a model called FANET, Flying Ad Hoc Network, using glowworm swarm optimization in 2019. They published in Physical Communication Elsewhere that how this GSO works using FANET, Flying Ad Hoc Network. So we also worked in some model called 2020. This is our paper with myself, Debashis and Aparajita Chaudhary. We have developed a model for limited grid mobility for swarm operations for the sensor networks or these drone operations. Limited grid means they each and every drone has some limited grid. Grid means it has some boundary. It will not go beyond the boundary. We call it grid. So like your area, every area has a pin code. The drone should not move away from this zone. They will transfer the data from one drone to other drones. So these are very basic operations. So we also use fuzzy logic for drone movement. So these are some of the research we did for drone operations. Advantage is that we can optimize the drone mobility and we can minimize the drone accidents, collision, right? So we can optimize the speed, angle, patterns. Speed is important. What is the speed they will to avoid the collision, speed is important. Direction, angle, patterns, location, everything is important for drone mobility. Okay. Nowadays also drones are used for lighting system, drone lighting. Anyone has seen drone lighting system? I think it's very common and popular nowadays. Have you seen? On the television you must have seen, right? They are making various patterns, multiple drones going on the sky. They are making various patterns on the sky of Gitter or your country or like this. Anyone has seen it?
Yes, sir.
Some special marriage ceremony is happening in India. Can anyone tell which marriage ceremony is happening now? Everyone knows, right?
Ambani, sir.
Yeah, Ambani, right? Anyone has seen followed their marriage ceremony? Even the drones are used there to display their family history and everything. Whole story using the drones. Unbelievable. It is available in YouTube or various media. These videos are available. You can look at it. They're creating the picture of their family and everything on the sky using these drones only. Mind it. It is used there marriage ceremony. Okay. It is pollution free, right? No pollution. Country like India, in Delhi, there's lots of pollution. Especially after Diwali, pollution is very high. If we can make a Diwali using these drones, we can do it. Even in our IPL matches or in Olympic matches, right? We can see these drones are doing great operations, right? They are doing various kinds of patterns on the sky. How it is happening? This is the picture. This is before the flight. Before the flight, drones are lying on the ground like this. Initial pattern. When the signal comes, what happened? This is before initialization performed. When the drones like 3D lighting, we have to program the drones, multiple drones. They will take the coordinate on the sky like this, based on the operation. So you have to give a command, software-defined radio or software-defined command, so that this guitar will be found on the sky for 15 minutes or 30 minutes like that, based on your flying time, right? And here the drones connected with lights, red light, blue light, yellow light. If you want to make a flag of India, you can arrange the lighting accordingly, right? All the drone lighting systems accordingly. Is it clear or not clear? This is basically coordinate formation. Okay. Especially lots of programming and coordinate formation is available. You can see, and some of the work we did for social IoT for 6G network also. I'm not going in details. 5G, 6G is now so already in the market. Especially we did some of the works for healthcare using this stride analysis. Those who are interested, they can go through it. What is that? Actually, using the drone, Using the drones, we can do this stride analysis. Stride means how the person is walking. Drones can watch at your walking pattern. Real-time stride analysis means how your leg movement, how your knee bends. Using this 5G or 6G network, these drones can handle that situation, that how this this healthcare things can be detected. It can also detect what is the disease you have based on your movement pattern, based on your walking pattern. So that is called real-time stride analysis. Stride means how your movement of the leg. It is possible through drones. Especially you can see the movement of the legs like this. Various protocols we can develop using MQTT. So this is for drone has lots of applications in healthcare. Lots of applications. We also work for this edge Dew drone. Dew drone is basically drone without internet or limited internet. Sometimes that when the drones are moving on the sky, what you can see that drones are moving on the sky, it has lots of what is the biggest problem challenge, and can anyone say? When the drones are moving on the sky, internet is the biggest challenge, right? They are on the sky, they will not get good internet connectivities. So we are using a Dew drone where even if the internet connection is lost for 30 seconds, 40 seconds, using the cache of the drone, we can reconnect seamlessly. So that is called Dew drone or Dew computing on the drones. We published this work in last year, 23, in IEEE Consumer Electronics magazine called Dew drone. Right? What is that actually? Every drone has some chip which has some cache memory. We call it cache memory, right? In the cache memory, data is stored temporarily. So suppose you purchased a very good iPhone or Samsung Galaxy, which can handle large amount of data, right? It has very good high cache memory, right? Cache memory, caching operations. What is the advantage? If the signal is lost for 30 seconds, this cache will store the data. This is also known as cache computing. It's very popular nowadays, especially for limited internet connection. If your internet connection is lost also for few seconds, it will not affect your connectivities or operations. So this is very important, called Dew computing. Also, I have written
Sir, I have
on.
one question.
Yes, tell me.
Sir, functionality-wise, are the drones who are controlled by satellites different from these kind of drones?
Yeah, satellite drones are different. Satellite drones can go from one country to other country, and these drones actually in short range and short height drones, right?
Okay.
You have seen those drones are used for Russia-Ukraine war. They are using by satellites. They're different.
Okay.
They're like flight. They're different drones. Okay. So if you are interested, you can see this operation. It's called Dew drone. I have also written one book, like in Springer, called Dew computing. The book name is Dew computing, where we have shown that how this Dew computing is inserted on these drones, so that even if the network connection is lost, drone cache can handle the data without losing any data. It can handle. So if you have been using any high-end mobile phone, you will not lose any connection. But those who are using this phone with less RAM, less cache memory in the mobile, you can lose the connection. Somebody called dropout, right? Dropout will be less if your cache is high. We call it Dew drone. Also, drones are used extensively for disaster management, right? Disruptions, disaster management in the cities, right? We published one work also for disaster management, IEEE transaction on consumer electronics, right? What is that disaster drone? What is that? We have used disaster management for 6G network. If you're interested, you can go through this. How this multiple drones are operating together for network slides. But for that, we need huge bandwidth. And that is the reason we are talking about 5G and 6G network. 6G has this capability to handle network slicing. Slice manager, service database, flow controller. These are the three important operations for 6G slicing. I think within 3-4 year, that maybe it's 2024, 2030. By 2030, it is expected in India also 6G will come. Then for disaster management, these operations can be handled. There's a technique called slicing, network slicing. The slicers are helping a lot. And you can see here is a edge processor is involved. See, drone-based edge processor is involved for this. This edge processor works in the slicing mode, network slicing mode. I'm not going in detail because it is another different subject itself, 6G network. I will not going in detail, but in 6G drone, both are actually very common. Means in 6G drone is basically edge computing is playing a major role, right? Because of the bandwidth is coming in the edge level, right? So those who are interested, they can go through this paper, how these drones can be used for disaster zone areas, right? Using these 6G slicing areas. This 6G slicing is not available in our 5G or 4G network. Slicing is a new technology. It is not available in our 4G or 5G network. Okay. And that actually helps in bandwidth management or network management in case of disaster management. Also, IoT is internet drones are used for blood delivery. One blood bank to other blood bank. If you need any, blood delivery system, you can deliver the blood one place to other place. Anonymously, without that this server stores your name. Say suppose I am Debashis, right? My blood group is AB positive. My this blood bank knows I am AB positive. They will send me the AB positive data only through the drones. But drone do not require to know what is my blood group. They will simply collect the data, tell my patient ID and patient name, Debashis there, and his corresponding medical ID. Automatically the AB positive blood will be delivered. So this is called privacy preserving technique for the blood delivery, right? Is it clear or not clear? Now we are going to the third part to provide this privacy using this federated learning or distributed learning techniques. Federated learning provides privacy. Privacy means that everyone needs privacy, right? Nowadays, Privacy Act has been introduced in our country and various countries. Your privacy, your data is your data, private data, right? Scalability. Scalability means what is scalable? Scalable means it can be. I said you that in our this Google platform, maybe Google platform maybe 100 user, 1000 user. Based on the usage, the scalability will be used, right? And the performance. These are the very important aspects of federated learning. Now, what happens in the drones? Suppose there is a drone 1, drone 2, drone 3. They are learning in the edge level. All the drones are edge layers. Can you see this W1? W1 line, red line. This data is going from one drone to the central drone. W2 is local learning of another drone going from local level to the centralized servers. WK is another drone. So WK may be 3, third drone can send it like this. By this way, the drones are collecting the data locally and sending the things to global system. What is happening globally? They are learning what is actually patterns of various zones. They make a global pattern. So actually, locally learning and global pattern, maybe summation of all this information, right? Then they, like our prime minister, they are getting the data from all the chief minister or local level, or municipal level, or in the Gram Panchayat level. They are collecting the data, W1, W2, W3. Then ministry in the central government, prime minister or the higher authority, they are deciding how many funds they will give it to West Bengal, how many funds to Delhi, how many funds to other states. So that is called W. W is the policy, local learning to global policy. So W is same. W1, W2, W3 is different. W1 is different because they are getting the data from West Bengal. That they are getting the data from Chennai. They are getting the data from Madhya Pradesh, right? But they are generating a pattern out, getting all these things. They are making a summation, and they are making a global model called W, and that W is delivered to all the models. So this is the machine learning model for the drones. So what you can see, locally learning and global aggregation. Locally learning and global aggregation. So it's called written local learning and global model. Global model means the policy, central policy, right? What policy center makes? Center takes the feedback from the user, from the states, from the chief minister, and they make their policy. What will be the food will be given to the farmers? What will be the policy for transport? Like this, the policies are different in different cases, right? Is it clear? Is it clear, anyone? Or not clear?
Yes, sir, clear.
I can give you another example. Do you use this? Everyone use WhatsApp, right? Everyone use WhatsApp, right?
Yes, sir.
See, when you are, which place you are, madam? You are from?
Odisha.
You are from? Which place?
Odisha.
Odisha, okay. And sir, which place you are? You talked previously, sir. Madam is from Odisha, and sir is from
Sir, Mumbai.
Mumbai. Okay, great. So we are getting good. I'm very happy that. So what, madam? What is your name?
Shraddhanjali.
Huh?
Shraddhanjali.
Shraddhanjali. Okay. So we are getting. Say, suppose this is a local area of Odisha, right? Actually, this week I am going to Odisha, Bhubaneswar. Okay, Puri, those areas. Okay. Now this is the local data of Odisha, right? What madam is collecting. If someone is from Mumbai, he is collecting the data from Mumbai, right? And many people are from Warangal, right? Sanjay sir is from Warangal, right? So he is getting the data from Warangal. So all the data W1, W2, W3 is coming from different zone, heterogeneous data, agree? And this centralized drone getting the data from various zones, and they are doing global aggregation, say summation or sorting. Then they develop a policy which is known as W. This W is same for all the cases. So W is called global model. See, W is down arrow. W is going to Odisha, W is going to Mumbai, W is going to Warangal, W is going to Calcutta, W is going to Chennai, W is going to Srinagar, all the places. So these are the W's, right? Same W. So this is also known as federated learning or distributed learning, right? So by this actually process, multiple clients, you know that we have lots of clients, thousands, 10 to the 10 to the 7 population. We are collecting only 100 device randomly, not randomly, totally randomly, based on the type of data. See, suppose you are using WhatsApp, we are collecting 100 WhatsApp user whose mobile phone quality is good, means iPhone or Samsung or very high end 1 lakh rupees phones, right? That means you are giving good quality of data to the server, right? This system knows who is having this, who's what quality of things. So by this process, they are collecting the data. See, and there is a old pattern model W, that is YOLO. Can you see this YOLO? This is the old model. After this 1,000 rounds, see 1,000 rounds going up means user to the server, training process, machine learning techniques, the learning process. See, model is developed. So what is the model development? 10 number of models are tuned with the hyperparameters. The engineer is doing this operation. After that, this is W1, this is W2, this is W3. After that, a new pattern has been generated. That is called red. Red means this is the new pattern, W. And this W is going to all 10 to the power 7 user. Clear? Ten to the power 7 means huge amount of user. Out of first, what you are doing, I am repeating again, we are collecting only 100 data from 100 users from various locations. Odisha, maybe this person is from Mumbai, I am from Calcutta. So we are getting 100 users from all over India based on the type of mobile. I have also very good, my mobile phone is around 80,000 rupees. So I have a very good camera, I have very good RAM. Based on that, my phone has been selected. Suppose your madam, you have iPhone, which has also very good quality picture. So those phones which has very high quality, they'll get good information. From that, learning pattern will be also good. They have 100 rounds of learning. It happens in your WhatsApp also. Same learning phase. What you are writing in the WhatsApp, what are you writing? ABCD, right? Whatever you are writing, chatting with your friends, everything is stored locally in your mobile phone itself, which is called local learning. After that, this WhatsApp takes all the data from all the users. They make a global pattern. Suppose in India, I for India will come, because most of the people writes I for India, right? But if the same modeling operation is happening in Indonesia, then I for what? I am talking about recommendation system. In your iPad, there is a recommendation system, right? Then if someone is from Indonesia, then I for Indonesia will come, right? Clear? This is the most important part. Any confusion or any question? So this is the local patterns. This is the global W. This is W1, W2, W3, and these are global W. Red patterns. Red pattern is a common initial patterns. And same working principle for WhatsApp. Those who are using WhatsApp, after say 7 days, you have to update, or after 1 month, you have to update your WhatsApp message from your Play Store or somewhere, right? Then during the update, you will get these red patterns. All the patches, all the learning data, all the NLP data will be downloaded in your system. Same logic, same working principle for your WhatsApp messaging. Is it clear or not clear, madam? Little bit clear?
Yes, sir.
Now, madam, is it doing privacy preserving? Is the privacy is preserved? See, in the local level, we are getting only 100 sample data, but data is going to 10 to the power 7 users. But they do not know who is the contributor, who is the 100 contributor. So they only get the good pattern W. So by this process, the identity of that 100 randomly selected people is not disclosed, right? Is it clear? 100 sample we are taking, but identity of the 100 sample is not disclosed. So we can you tell it that this process of machine learning is known as privacy preserving learning, because when this W red color pattern going to the 10 to the power 7 devices, they do not know who contributed to this pattern. So this is also known as distributed learning or federated learning or privacy preserving learning. This is the most important part. Okay. So you can see when drones, see here we have n number of 1, 2, 3, 4 up to n number of drones are there. They have their own local learning. They are giving W1, W2, W2, W3, W. And in the globally, all the patterns are summation. Wi, I equals to 1 to n. They are doing a summation, sorting. Then WG, global pattern is generated. WG is going to the all the drones. See WG means global learning. G stands for aggregation. Aggregation is G. Global. G for global. Okay. So by this way, actually, global pattern is delegated to the. See, in the process, most of the many drones are contributed, but WG goes to everyone, where the identity of each and every drone is not disclosed. So also we can tell it that this is the privacy preserving technique. Privacy is preserved. But sometimes what happens, some attacker, it's called FL attacker, they want to disturb the pattern. Coming that they are giving wrong pattern, they want to do the things, these are the different things. These are the challenges, cyber security challenges, right? I'm not going in detail of it, but that can be mitigated. They're using blockchain and other techniques. See, these are all the W1. Same thing we have discussed here. FL attacks like this. Our drones are always under attack, especially in the border areas. Always someone want to hack you. And this is the summation, what I've already discussed, mathematics of summations. So this is the basic process of operation where drones are getting the data from the mobile phones and the users, and they're doing local learning here, second level, third level, and global level learning. So this is called mobile-based crowd sensing also. In order to handle the huge amount of data, we are using nowadays quantum key distribution, quantum computing. I'm not going in details of quantum computing, but quantum computing is a centralized operation because there are thousands of drones, right? Thousands of drones. We works in the bit domain, but this quantum drones works in the quantum bit level, where all the drones are connected. Quantum computing is more powerful than the normal computers. Nowadays, companies like Google, even IBM, they have the access of these quantum computers. So see, when you're talking about global aggregation, global aggregation problem is you have to handle huge amount of data, and you have to generate data for all the drones, and the computation is very high. It may take 7 days, but if you do it in quantum computer, it can be done in fraction of second, right? So that is the reason global aggregation is done by these quantum computers. So by this way, actually, we are doing this whole operations in a very faster operations. So what I can tell you that drones are now very intelligent enough to handle the smart cities. We can also we have already discussed that we are using federated learning for privacy preserving, right? Also, we have suggested to use quantum learning or quantum machine learning for very high-end global aggregation of data. So by this way, actually, we can perform the whole operations of the Internet of Drones, right? So I have also written one book, which is published in Aerospace Engineering series of Elsevier, called Internet of Drone Things. It is in the final stage of editing. It is in the press, actually, in press. So maybe in April, May, June, you will get it in the online, right? I hope that I have given some idea how this drone operates, and I hope that any confusion you can reach me. This is my contact details. Is my WhatsApp number. So any confusion, you want any PDF or my research papers, I can share you. Okay. Thank you. Thank you, everyone.
Thank you, sir.
Thank you. You got some idea?
Yes, sir.
Sir, I have a question.
So
Sir,
yes,
for
yes.
underwater drones, the how you are getting the bandwidth or signal wirelessly? If it is, what is the status?
Yeah, underwater generally till date I have used not wirelessly. If you see my picture, this drones I'm just showing you there. Yeah, this one. This is underwater drone. We are actually connecting a cable. Uh, we are connecting a cable. Cable means
Yeah,
wired cable.
in cable we can get the bandwidth, but wirelessly the
Wirelessly, there is a research challenge, and we are doing
it's
research on
still
this.
not.
Yes, yes, there is a research challenge. We are working on it. Yes.
Okay.
And this is a very important question you have asked. We developed some wireless module for it, but it is under patent, so I am not disclosing it. But if you are interested, we can work together. No problem.
Okay, sir. Thank you.
We have some couple of patents on these drones, wireless drone operations like this. Okay. And very interesting. This underwater drones even can be connected to the drones flying on the sky. They can be connected. Okay. So we are making this kind of ecosystem. The Shargo Morto Patal, that means 3 layers. Underwater, even the sky or the land, everyone can be connected. That is why you can tell it Internet of Things or Internet of Everything, right? That is the operation. Okay. Is it clear?
Yes, I got it.
Okay. I have this drone in my lab. My students are working on it. Even I can tell you a very interesting challenge. If you go for River Ganga, it's called sweet water, right? If you go to sea area, salty water, the picture and the data collection is very, very, very difficult. So we are facing a lot of challenge. Lot of research scope is there, especially for underwater. It is less research is done on underwater, yeah. And the fishermen's, they're using these underwater drones to catch the fish in many countries, yeah. They can see the flock of birds, a flock of fishes under the water, they can catch the fish. Okay. Is it clear? Or any other question, or it's okay? Madam, is it clear?
Yes, sir.
Okay. You got some idea?
Yes, sir.
Okay. Thank you.